Nuclear chemistry, day 4. How do we determine the uses for selected radioisotopes? Over here is the do not question. I'd like you to complete it. Look at the missing element, which is right here. Well, 3 on the left plus what gives me 4? 3 plus 1 gives me 4. 1 plus what gives me 2? 1 plus 1. Well, atomic number of 1 on a periodic table is the element hydrogen. Now, what type of reaction is this, guys? If hydrogen plus hydrogen gives you helium. Well, that is a fusion reaction because that's combining of light nuclei. We learned when you have, 2 on the left, 3 on the right, that is a fission reaction. Okay? All right, let's move on. Radioisotopes and their uses. All right? All right, guys, so this is something you just have to memorize. All right? Iodine 131. Well, guys, here is your thyroid. Your thyroid is what regulates basically your metabolism. Okay? So, unfortunately, if you get radiation exposure, the radiation normally first goes to your thyroid, which regulates, your body's chemical reactions. And what happens is, or your metabolism. And what happens is to try to combat that, what we do is doctors or scientists will give you I-131. Okay, iodine. Iodine helps to combat thyroid disorders. Okay. Now, over here is a scan of the human brain. So, as you see, different parts of the brain light up during the scan. Unfortunately, the parts that don't light up many times are the ones that are the tumors. So, the next one you have to memorize is called TC or technetium 99. Okay, technetium is the atomic number 43 on the periodic table. Technetium, which is actually radioactive, okay, helps to determine brain tumors. Now, you've seen C14 before, correct? C14, going back to earth science, C14, all right, is used for different types of dating to see how old different things are, like maybe trees or animals, right? Because carbon is the basis of life. Okay, we're all carbon-based creatures, right, guys? So this is for organic dating. If you want to know how old something is organic, okay? We're organic. A leaf is organic. A plant, an animal, an insect. They're all organic. And by the way, see over here, that's pretty cool, right? This again shows whenever you have, let's say, any type of test done, MRI, PET scan, CAT scan. Well, MRIs, no, there's no radiation, which is just magnets. But PET scan, positive emission topography, CAT scan, which is basically another type of radiation. Those two types of radiation help to determine whether you have cancer or non-cancer. Okay, or can fight cancers. Okay, let's move on. Another type of dating over here. It's called U-238. U-238 is called, well, this over here is uranium. Uranium is for what's called mineral or geological dating. Okay? Oh, by the way, these are your kidneys over here. Again, you can use radiation. Here's your urethra over there. Okay. Now, CO60. CO is cobalt. Well, easy way to memorize it. Cobalt cancer. Okay, TC tumor. Cobalt is for the cancer, is for the treatment of cancer. Now, you might know someone, a relative, a friend, who's undergone cancer treatment. Okay, they usually go in this machine, all right, for radiation. Okay, that machine gives off radiation. And one of the treatments they use is cobalt 60. That's for cancer treatment. Okay, so let's recap what we learned so far, guys. All right, we learned so far that iodine 131 is for thyroid disorders. TC99, right? This over here is for thyroid. TC tumor, brain tumor. Carbon 14 is organic dating. Next, excuse me. Next over here is U238. We said that's mineral or geological dating over here, right? And cobalt 60 for the treatment of cancer. Okay, let's move on. All right, so we spoke briefly about this in the beginning of the chapter about radioactive particles. Now, you notice how the fruit on the right side over here start to spoil? Well, what farmers will do, but and unfortunately in most states it's illegal still for some reason. But a lot of people die every year because of what? The different types of bacteria, salmonella, poisoning, which is found sometimes on eggs and chicken. E. coli bacteria, which is found on fruits and vegetables. That's from fecal matter, poop. So what they could do is simply add a gamma ray. Remember we learned gamma rays are the most dangerous of them all? We have a high, those are the wavelengths. But they can be used in a positive way because gamma rays can kill yeast and molds and their eggs of insects or whatever. So it prolongs the shelf life of food, makes food last longer. Okay? By the way, if you irradiate your food, you do not actually, food does not turn radioactive. Okay. So let's move on. So that's why, guys, if you go to the supermarket, don't buy dented canned foods, because dented canned foods, a lot of times a little microscopic dent means there's a little opening now which allows bacteria to go inside and multiply. So don't eat dented canned foods. Radioisotopes, right? If you ever gone to a doctor, your parents, they might have had colonoscopy or whatever. They have to drink this solution before they have it. What it does, it highlights the whole inside of the body, of the colon, so then they can actually take pictures and determine whether or not you have any growths or anything like that. It's easier to see it. So radioisotopes should have a short half-life. You don't want something that's radioactive that lasts long in your body, right? And be quickly eliminated from the body. Okay, let's move on. Last thing I want to talk about, guys, is a nuclear power plant, all right? Here's an example of the inside of a nuclear power plant. Again, you've driven along, if you left Almont and you went upstate New York, Pennsylvania, Delaware, New Jersey, some parts, okay, you're going to find nuclear power plants. It's these guys over here. Nuclear power plants, we said, are basically these big smokestacks with like white smoke coming out, because that's steam. All nuclear power plants are built along rivers. Because what they do is they draw in cold water from the river. It passes through the turbine. Well, it passes through the heating coils in there, which can reach thousands of degrees, and then turns to steam, and the steam comes out and spins the turbines, which then produce electricity. Okay, so let's go over the benefits, guys. The benefits of fission reactions. Fission, remember we said fission when you're splitting the nucleus. Think of the atomic bomb. Okay. Well, there's no greenhouse gases. No CO2 is emitted. Okay. No other types of greenhouse gas. No methane's emitted. No CH4. And it also produces large amounts of energy. In other words, these nuclear power plants here can actually power cities, okay? But now, what's the problem with nuclear power plants? Well, if you're a worker there, you can't work all year long. They give you a radiation detector. that you wear in your shirt. It's exposure of radiation to workers. Okay, because again, too much exposure to radiation can lead to what? Cancer and other genetic mutations. Radioisotopes, these guys, some of them last for up to 10,000 years. The byproducts of the radioactive process. So you have to store them somehow. So there's difficulty in storing them and disposing because you cannot just simply just dump it in the river or in the ground. It's going to eventually go to a water table or whatever the case is. All right? So benefits of fission reactors. No greenhouse gases. Produces large amounts of energy. All right? No greenhouse gases, and produce great large amounts of energy. The problem, workers can be exposed to radiation, which cause cancer and other problems. Radioactive isotopes, or basically reactive particles, have long half-lives. In other words, they last around for thousands of years. And difficulty in storing and disposing of radioactive waste. All right, guys, I have a couple of clips over here. You should look it up. Reactivity and its uses, X-rays, Chernobyl, Fukushima, and that's it.